All right, welcome back. Wonderful third period class of geometry. Most of you are 10th graders. Glad to hear that. So we are moving on to geometry. This is called Geometry 1 through 22, Transformations, EOC practice. Make sure that is marked clearly at the top of your scratch paper, which you're going to want to turn in. Because the scratch paper is what I'm going to put in Skyward, not the submission from here, all right? Although I want you to do this on the Google form. Okay, let's dive in. We're going to be doing some transformations. We're going to be moving the graphs of objects around and seeing what happens with them, all right? So the first question is, what is the line? The first question is actually a fairly difficult one because it's not multiple choice. It requires you to type it in. So what is the line across which the pre-image was reflected? So we're reflecting, we're not rotating, we're reflecting. So this point corresponds to that point corresponds to that point, this point corresponds to this point. Part of what makes this one a little bit hard is it's not very clear what the axes are. So there's your y-axis, there's your x-axis. I mean, they do have little arrows at the end, but they're very, very faint. So if you know your rules, then you know if all we're doing, this is 3, -1, this is -1, 3. If we're just switching our x and our y, we are reflecting around this wonderful 45-degree line that is called y equals x. It's the identity function, y equals x. It creates this line right through there, and it's things where a lot of things will reflect around it, okay? So type in y equals x and you will be golden. What are the vertices after it's reflected across the x-axis? So I always, we had that fun little sort of craft where we cut out and labeled the different types of, actually that was more for rotation, and no, it was for reflections around the x, reflections around the y, reflections around y equals. So I never remember those rules, but you can kind of make them up. Okay, let's just take an example point. This point right here is 4, 1, right? Let's reflect that single point around, that's 4, 1. Let's reflect that one point around the x-axis. We're going to make it over here. It's going to be at 4, -1. So there's your rule. We're just changing every y value to negative, changing the sign of it. We're making it negative. We're making it to the opposite. So what are the vertices? This would stay the same because we're reflecting around the x-axis. This is, right now, this one's kind of hard to tell the axes also. So this is 1, 3, so it's going to be 1, -3, 1, 2, 3. There's our new point. 1, -3 would correspond to C, 1, -3, and then B would end up, it's -2, 1 now, so it'd be -2, -1 would be your B prime. -2, -1, B prime. And then A stays the same, 2, 0. So there's your three answers, M, S, and T. All right. If a figure is translated 2 units up and 1 unit left, then translate it again. How would you write the composition of transformations? Now I know we never talked about this type of transformation notation, but it isn't hard to figure out. It just means the x's are moving in this direction, in that the x's left and right are moving in this direction, and the up and down is moving in that direction. So if we're going 2 units up and 1 unit left, that's the transformation for this first direction, okay? And then the second direction is 5 units right and 3 units up. So we can just add these two together, basically. This is our x and y transformation for the second direction. This is our x and y transformation. They kind of tried to fool you and tell you the up first, but we know that that's y. So we're just going to add these, and our final would be 4, 5. So all of the x values would move right 4, and all of the y values would move up 5. So 4, 5. Incidentally, when I was keying this in and putting the answers in, it said the answer was A, but I'm going to disagree with that. Even people that write textbooks do make mistakes, as we've learned this year. So X, Y, Z is an image of a translation of ABC. A is at 1, 1. X is at 5, -2. What translation maps these two? So A is the first and X is the first point. So those do correspond. All we got to do is decide what happened from here to here, 1 to 5. I would call that right 4. And then from 1 to -2, I would call that down 3, right? And I actually, when I was working this out, I actually put it on a little XY chart that I drew real quick, and you certainly could do that too. So I would call that A right there, 4, -3, moving all the x's right 4 and all the y's down 3. All right, what's the transformation of the maps ABC onto the image? So I got this confused. This is the pre-image, the A, B, and C. This is the new image, okay? So all you gotta do is just go from A to A prime, but we gotta go in a left-right direction first, because that's our X motion, and then an up-down, and that's our Y transformation. So 1, 2, 3, 4, 5, 6. 6 units left. Left is negative. So -6 on the X, and then 1, 2, 3, 4, 5. 5 units down. 5 down is negative. So there's our transformation. So -6, -5, we would have D right there. All right? All right, suppose GFE is the translated image of ABC. If the translated rule is this, here's your rule, okay? Left 2, up 5. Where is point F? So here's what we gotta do. We gotta figure out what F corresponds to. F is the middle of the triangle, and it corresponds to the middle of this triangle. It's not the middle of the triangle, it's the middle point as the triangle is named, but they do correspond, so F would correspond to B. So now we just gotta find B and do the transformation. So we're gonna go left 2 and up 5. 1, 2, 3, 4, 5. There's where B ends up right there. There's B prime right there. So that is 0, 3, 4, 5, 6. 0, 6. There we go. That would be P right there. Okay, moving on. How does a reflection map each point in the pre-image to the image? Reflection map by a fixed distance and direction. Maybe. We're definitely not expanding or contracting it, right? It's not a dilation. By a fixed number of degrees about a given point. No, that's a rotation. By a scale distance from a given point, or by movement across a fixed line. We're going to move that thing across a fixed line. It's going to be S. Hey, how you doing?
Hey.
Just preparing some stuff for being gone next week.
I seen your light on and we didn't think anybody was here.
Oh, yeah, yeah. Do y'all need the room?
No, not right now.
Okay,
No,
great.
no.
All right, so we're going to select all the transformations that do not preserve distance. Dilation does not preserve distance. Let's see. Reflection across Y equals that preserves distance. Rotation clockwise preserves distance. Dilation does not. Left and then a reflection preserves distance. Dilation does not preserve distance. So we're going to go with A and E on that. When they say distance, they mean distance between 2 points or the length of a side of a figure, all right? Or distance from something. So let's make sure that we're at A and E on that one. All right, yeah, A and E. I have to check myself too sometimes because it's a lot of information to keep in your head, and I know it is for y'all too. So what are the vertices of the image? We're rotating 180 degrees around the origin of ABC. So the vertices, we're starting off here, here, and here, and let's see where we are. 180 degrees. So this is, we did have these rotation. We had another craft where we had the rotation rules. And again, I always, for rotation rules, we're rotating 180 degrees around the origin. So we're going to be, instead of 3, 0, we're going to be over here at 3, instead of 0, -3, we're going to be over here at 3, 0. And so that's going to rotate over there, and then this one's going to end up right here, because what is the rule? This is -3, 0. This is 3, 0, so we're just changing our x value to rotate at 100. We're changing the x, not the value, but the changing the sign. And then this is 1, -1, so we're going to make that -1, -1. So that's C prime, -1, -1. So I'm going to go with this one for now. Let's see. A prime, but then A prime doesn't work. A prime is still where it's at -3, 0. So 3, 0, -1, 1. Oh, okay, yeah. -1, 1 ends up here. I was getting a little confused by these, right? You remember the rules? The rules can get a little confusing. But if we're rotating 180 degrees, let's do it another way. Let me remind myself of the rule. So if we were here at -1, 1, and we rotated 180 degrees, we would end up here at 1, -1. So we're switching our x and our y. That's what we're doing. We're switching our x and our y. So 0, the 0, negative 3, 0, 3, 0. Negative 1, 1, and then this is negative 2, so it's going to end up at 2, 2. And I hope I got that one right. I should have looked these rules up before doing this. These rules do kind of confuse me a little bit. Look those rules up. Find your little craft that has the flaps in there, and we'll go from there. Write a transformation rule for the coordinates of the point that is rotated 90 degrees clockwise around the point. Right around the origin. Write your answers as an ordered pair. So I always remind myself, what is the rule? So if we're at negative 1, 3, negative 1, 3, and we're rotating 90 degrees counterclockwise, we're going to end up right here at 3, 1. So negative 1, 3. So we're switching the x and our y and changing the sign of the y value. So we're switching switching x and y and changing the sign of the y value. All right, now let's see what I put as the actual answer there. X, y becomes y, negative x. So you switch them and change the sign. But I'll just work that out on as we go. Which type of symmetry does regular pentagon have? So just a quick reminder, rotational symmetry means it can rotate about its center and eventually line back up with itself, become itself again. And that is true of this pentagon. Reflectional symmetry means that you can create a point of reflection, or it's like line symmetry. That's actually what we called it in our curriculum, is line symmetry. So this one does have reflectional. And then point symmetry as well, because there is a point at which it can fold or reflect. So let's make sure that it is all three. Yes, it is all three. All right. How many more do we have? Oh, this is a 1 through 22. This is a 1 through 22. So I'm not going to have time in this video to do all of them. So carry on with this lesson. Keep your reflection and rotation and translation rules in mind. Look at the book. All of this material is open book. Please look it up. Talk to your friends, okay? Talk to the people around you. Ask them, not what the answer is, but how they figured it out. Okay, and we'll go from there. That's it for this video, and we'll go on to another one.